Oh, okay. I think we're live. Yes, we're live. Hello, everybody. I'm gonna wait just like a minute or so until we'll all be here. Um, I will be looking at chat most of the time, so please let me know if you can hear me, if you can see me, if you have any issues. Just ping it over chat. I will walk you through the whole mysteries and stories and well, basically all of it. Okay, this is good. This is good. Nice to see you all here, guys. That's really fun. I think I'm gonna wait like literally just one more minute, because we started on point, on time, and we all want you to be here. Nice. Cool. Okay, 91 seconds. I think that's enough time for me to start. So again, hello and welcome to our digital DevOps playground. I'm your host, Artur Kondas. I'm gonna walk you through magical stories about Go APIs, CRUD APIs, RESTful APIs, whatever you want to know basically about them. So just to begin, what DevOps Playground is. DevOps Playground is a community of like minded people, and we want you to learn new stuff, good stuff. And I don't know why my screen hasn't switched, and this is bad. I'm gonna switch it manually, it's gonna be better than this. Yes, okay, cool. We are here. Nice. Uh, Already first hiccup, but doesn't matter, it's live. It's gonna be fun. So, as I said, it's a community. Join us on meetup.com. Find us on any social channels. We will be always here to help you and to teach you something new. What are we going to talk about today? We're gonna talk about Go CRUD APIs. CRUD stands for create, read, upload, update, and delete. And we will create one API ready to deploy from start to finish, both with Docker file, and it will all be ready to go. Okay, I'm gonna check quickly top chat. I'm gonna turn the volume just slightly up because I can see the meters being quite low. But yeah, okay, cool. So, who am I? That's probably the first thing you want to know. I'm a Go developer at ECS Digital. I do a lot of open source stuff. I'm a software generalist, but mostly doing Go. I also do a lot of pizza and bread. Yeah, like I bake bread, I bake pizza. Yeah, there's a lot of stuff. Um, yeah, if you want to read more about me or read more about, find more tutorials about Go, find me at akondas.com. Down here, I guess. No, the other way around. Yeah, so bit.ly slash dpg cheat is the cheat sheet I've created for you, um, which will help you to go through the material we have ready for you today. But before we will go there, no pun intended, we'll talk what's Go, because well, it's a Go based playground, so it would be nice to actually know what's Go about. So, Go is statically typed compiled programming language designed at Google by Robert Griesmer, Rob Pike, and Ken Thompson. Robert Griesmer is the guy who wrote the V8 engine for Chrome. So, if you use JavaScript and you run it on Chrome, uh, well, Robert Griesmer made it possible. Rob Pike and Ken Thompson, these two guys wrote Unix system, like literally designed and wrote it. So, if you're running Linux or if you're running Mac right now, well, say thank you to them. Nowadays, Go is a backbone of a lot of DevOps tools, from Docker to Terraform to Vault to Kubernetes, Prometheus, Helm, Loki, Grafana, all the keywords any recruiter wants to see on your CV. So you can ask them if they are DevOps tools or Pokemons. Yeah, but that leads us, why do Go? Well, Go has type safety, so as it's statically typed, every single variable has to have a type. We will touch on that pretty heavily in this playground. It is very performant, it's super fast. Go compiles into Go, so Go compiler is written in Go, which is also fun, and it has literally, honestly, one of the best documentations I've ever seen. Doesn't matter what the package is, Go can generate the documentation for you, and there is a very big community behind writing a proper documentation. And in our world, if you're a DevOps engineer, there are chances that you use Docker or use Kubernetes. It's actually really good to know how it is written and what's going on. Yeah. So, okay, so before we will begin, before we will do anything, if you go to bit.ly, so if you type bit.ly dpg cheat, yeah, if you do this, you can see all the documentation I created for you in order for you to work with us today. So the first 3 links that you need to know, the first one will lead you to the instance. I'm going to show that in a second. The second one will lead you to our support channel, where the rest of our DPG family will help you with any problems you might have. And the third one is it's a shameless plug if you want to read more about me. If you don't, then please also click it. Yeah, so the first one, get your instance. So we've created this for you. So each person on today's playground will have their own instance, so can go from start to finish together. You don't have to do any setup before yourself. So if you type your meetup username, as you check our chat, there's a link already there as well. So if you type the meetup username, click submit, you will get all this beautiful stuff. So you will get the instance, you will get the username with which you have to connect, and then you will get the password. If you want to use it via browser, you can do, in my case, ferret.devopsplayground.org/wedi, and then use the password to connect. I will be using SSH. So yeah, I'm gonna connect through the SSH, and for me it will look like this. So this is my instance. Our instances are prepped for you with Vim, with Go in the newest version, and with the copy of our repo on which we will work today. I'm gonna check the top chat and our chat in general if there is anything. Yep. So far, so good. That's good. That's nice. Okay. So, if you use browser, then as I've said, this bit, so the instance name /wedi, and then it will get you where you need to be. If you use SSH, it's just SSH at SSH, the password, and in my case it's ferret.dpg Devil's Playground and org, and then if you type it, then it should take you where you have to be. Well, I'm not gonna type it here because I'm already SSH'd. Yeah, okay, I'm gonna give you like 2 minutes, so if you have any questions right now, you can smack them into chat. I will be happily answering this, and then we will get going. Okay, if you have any issues with logging into the instance you have, the quickest way would be to type it on our Slack. So we've probably prepared some instances if you're not on Meetup and if you heard about us. So we will have some extra instances for you, but please head to our Slack channel and we will help you with it. That said, while you progress, I'm gonna show you what we have on our instances. So first thing that you might see in the left corner, you can see all the commands I'm gonna type on my keyboard. I'm using Vim. You will be using too as well because we've prepared the whole every instance with Vim. So in order to not to get lost if you haven't used Vim that much, I thought, well, giving you the keystrokes also helps. Yeah, so if we cd into our hands-on directory, let's print it all. This is what we have in our directory. The most important thing for you is the cheat sheet. Cheat sheet is the copy of the one you can see on Bitly. So this is literally the same thing. If you need some referencing, it's gonna be there. If you need to understand what just has happened, it's gonna be there. And we're gonna work it out. So, I can see that we're moving through. Okay. Cool. Okay, I think we can start then. And we can work something out. So, as I said, we're gonna use Go. And we will write the whole application according to the standards and techniques that we have right now in the current place in time in Go. We're working on Go version 1.14. So this gives us the very nice thing which is called Go modules. Go modules is the way how we deal with dependency management in our application. So if you want to run the application, you would type go run dot or go build dot to create the binary. So if I will do it right now, if I do go run, nothing happens. So you can see we have a ton of errors, cannot find package, we don't know what's going on. Well, we basically cannot know what's going on because this is the first time we started working with Go. So the best practice right now is to create a Go module. So how to create a Go module? We type Go mod init, and then we have to name the module we want to add to our application. So in our case, it's gonna be Go CRUD API. The right hand side, so the Go CRUD API, doesn't matter. So if you want to name your thing, I don't know, go, yeah, you can do that. If you want to name it whatever, it's gonna work. I'm gonna ping it here. Okay, so once we have that, and let's print everything we have, you can see that we have Go mod. Okay, fine. Let's inspect what Go mod is. So if you typo Go mod. So right now it has the name of the module and it has the version of Go we are using. Okay, easy peasy lemon squeezy. That's all we need to know. And since we've started our Vim instance, we can do one more thing. So the instances we've prepared for you are they are basically blank. The only thing we allowed you to do from the basic Vim is to use mouse and to use arrow keys. But the thing I want you to do is to type :plug install, something like that. So then you type enter and it should split into two. And then you can read that it updates a lot of things. What it does, it fetches a very nice plugin for Vim, which is called Vimgo. And it helps us with syntax highlighting, with checking types, with checking errors, with getting the documentation into our project while we type. So it is very useful tool. So we're gonna wait a second to work it out. Yep. So the command is colon. I can't type it here. So the command, I can't do it right now as well. Can I? Yeah. So plug install colon plug capital P capital I plug install. And then it does a lot of stuff. We just have to wait a second because you need to fetch everything. I'm supposed to play some music here. Like I was actually thinking about playing some music right now, but then it's YouTube. It might be problematic. Cool. Okay. So we should have all of this ready. Okay. Then you probably read a lot of jokes about how to exit Vim. I'm not gonna joke around. If you want to exit Vim, you do :Q, and then it exits Vim if you don't have anything to write. So if you have anything to save, then it will exit super easily. So again, :Q, we exit it. Okay, cool. We have modules initialized. We have our Vim instance ready. Let's roll. So I'm using flat structure in our Go program. So there are few ways how you can structure your Go application. I'm using a flat structure for the sake of being easy and for the sake of it being very transparent, because you can see everything we have in our application. The most important file we have right now is main.go. So let's inspect what we have in main.go. So vim main.go. Okay, as you can see, I've made a lot of comments for you. So if there's something that you don't understand, 9 out of 10 is gonna be commented here, so you can follow along as we run. I will highlight the most important stuff. So let's move to line 14. To move in Vim, you can do :14, and it will move you to the line you want to be at. So in our case, line 14. So this is the very first, very important thing we have in Go. So package main. If you come from Java or if you come from C, you would have to define the namespace in which you work. Go works very similar to these languages, given that Mr. Rob Pike wrote the B programming language, which is, well, before C. You have to define in which package we work. So in our case, we work in package main. Package main for our compiler will say that, okay, this is a thing we want to compile. By the end of our journey, we want to compile that file, and we want it to be ready, and we want it to be executable. If it's named differently than main, it won't compile, because then we show the compiler, okay, this has not to be compiled. This is a package we will use in our other application. In our case, we keep everything in one package. We will divide it into separate files for readability, but we don't want to switch into different packages for the sake of clarity. Yeah, okay. So once we have that, let's move along. Then we have import. Same as you have in JavaScript, and you have to fetch any Node module if you work with Node, or you have to fetch any library you have to if you work with React. Same we have here. The very good thing about Go compared to JavaScript is that a lot of libraries are built in from the ground up. So if you don't have any host in front of the library, it is a library within Go. We call it standard library. I can see a typo in my documentation as well, but yeah, it happens to the best of us. In our case, we will fetch the package log and we will fetch the package OS. What do they do? I will explain in a second. Alright, so then we have func main. If you want to create a function in Go, you don't type function, you type func. This is how the language is designed. We use curly braces everywhere. So if you go line by line, this is the first function. Actually, it's not, but for the sake of until we will go to the next function, let's pretend this is a function that runs first. So we have a func main. When you run the application, this will be picked up first. So then this is one of the best practices how to write APIs in Go. So instead of using global variables, we create a struct that will hold the variables for us, and we will be able to call them from wherever in the application we are. So in our case, we can call this whatever, but I'm going to call it A, and then assign type app. So if you want me to explain the line, this is the name of the variable, then this is the assignment operator. So colon equals assign the variable, the type of the right-hand type to the left-hand name of the variable. So in our case, we create an app struct. So if you look at the left-hand corner, the left-hand down corner, you can see that vimgo tells us this is type app struct. What is app? We're gonna see in our next file. But this is one of the best patterns you can do in Go if you want to build something. Then we have two functions that will deal with initialization of the whole server and running the whole server. So initialize will deal with all the connections to database, to database we have to do, all the handlers initialization, I can't speak, and then set up everything we need for our server. Then run will run the server on a given port. Okay, so this is what we have. Then, as a light to you, sorry about that, but for the narration purposes it was better to do it, we have func init. Func init is a very nice function that allows us to run something before main even starts. So the best practice right now here is to run the checks on environmental variables. In our case, each instance for you is preset with 4 variables, which is username, password, host, and the name of the database we use. So we've created for each of you RDS database. You don't have to worry about setting this up. We've set it up for you. So we need to check in our application if those keys are present in the system. Because if they're not, we could check them in the runtime, but this is a very bad practice. This is a very bad practice to check your keys while the application runs. So if you're a DevOps guy right now, you probably have cold sweat and shivers that somebody would do it. Yeah, people might do it, so this is why we want to prevent that. So in our func init, we will check for all the keys we need to check. So we have one check for PG username, we have second check for PG password, we have third check for PGDB host, and we have to add one check I'm gonna check if everything's fine. Yeah, we have to add one check for PGDB name. Okay, so let's roll. So as you probably can see, I'm using if statements. If statement is a conditional statement, so we need to check if some condition is true. So this is again one of the best practices in Go. If you need to check some value, you call the variable as okay. So if you go to, for example, Kubernetes source code, there's a lot of checks like this. If you go to Grafana source code, for one of the PRs I've made for them, this is one of the best practices you follow, because then we know that this is some kind of a check. So in our case, let's type if okay, then we need to create and assign a variable, and we call package OS. So OS means it's a system, something that connects to the system. Let's leave it as this. Get env, so this will get the environment variable, and then we have to check pgdb name. So pgdb name. Okay, once we have that, semicolon, okay, equals empty string. And I'm gonna stop right now here. I'm gonna check the chat. So funkinit is like constructor in a class for initial setup. It is and it isn't. Go doesn't have a concept of OOP. It deals with OOP in a different way. I'm gonna explain that in server when I have the example for it, because right now we will just miss the tracks. So very interesting thing about Go. Go doesn't have a null concept. So the same as you have in many languages, something is null. So you can assume something is empty. It doesn't work like this in Go. Go has concept of zero value for each time. And it so happens that the zero value for our string is an empty string. So we check if our environment variable is an empty string, then we need to do something with it, because this means that the environment variable doesn't exist. So we need to say to the user that, hey, you haven't set it up. So we do _ln. I'm going to explain that in a sec. pgdb name not specified. Okay, what happened here? So we use package log. Log is one of the ways we can print something to standard output. So it gives us a very nice format of time, and you can see the time. If you set it up, you can see the whole trace of where the log has been called. It is a very nice thing. And then we have fatal ln. So fatal ln is basically log print line. So it prints the line, and then it calls OS exit 1. So what happens is that the user will be notified in the standard output, will print something, and then the function fails. So the application fails and it says, okay, it doesn't work, you have to set it up. Yeah. Okay, cool. So I'm gonna wipe it as well. So we have the same as any other check. If okay, colon equals os.get env pgdb name, and okay is an empty string, then it means we don't have this variable. And this is the most beautiful part. If you haven't worked with Vim, this is the thing which will save you a lot of hours and a lot of Stack Overflow. So if you want to save, you do :w, and it will save the current buffer. And if you want to exit, save and exit, you do :Q. And congratulations, you wrote your first Go code, which is fun. Okay, so I can see the chat being mildly okay. If you have any questions, just type them. I'm gonna check in each bit if there's anything I can help you with. Yes, X does both W and Q at the same time. The problem is X deals with buffers in a different way. So there's the whole concept of buffers in Vim that we would have to touch on, but yeah. Okay, cool. So let's move on. Next thing we need to check is our server. So vim server.go, and here we are. So you already can see that my Vim Vimgo it's highlighting something. So let's go here. So these are the two packages we will use for our application to run. The first application is Gorilla Mux. It is a multiplexer. It is the HTTP multiplexer for Go. We will be using that for handlers. And then the second one is Chorus. So if you have worked with any front-end developers, if they have to connect into something, then from the browser they have to have some Chorus policies set up on the server to be able to run. There are very many ways how you can work around that. You can snap Nginx in front, and it's going to deal with all of this stuff, but it's a very good practice to have the Chorus set up in your application either way. Okay, let's move to type. So this bit, which you can see here, is our abstract. So as I've said, Go doesn't have classes as we have in any other languages. We have structs. So we have structs, and those structs have methods, and we can do interfaces on them. We can do a lot of very fun stuff. In our case, it's going to be that simple because we will have one struct that overlooks everything. It is, again, a very good practice to, instead of having global variables that will deal with certain things, to have one struct that will hold it all. So in our case, this abstract has two fields. The first one is a router from Mux, which has a pointer. I'm going to touch on pointers later on. And then the second one is our custom struct that we have written in another file, which is called broker. Broker is an package, is a part of the code that will deal with every single thing that has to be done with the database. We're gonna touch on that as well. Okay, so once we have that, then initialize. So you remember from main.go, we have function initialize. So this function, as I've said, holds the logic for spinning up the database and spinning up the handlers. So let's go line by line. So we have the new broker. Somebody asked about the constructors. Funking it. So this is how you can construct new object, new struct. So structs and objects will be basically the same concept in different languages. So this new broker is a custom function I wrote that will return you the broker. So if you have to do any sort of pre-setup, you can do it there. We're going to touch on that as well. Okay, so we have this. Then we will get all 4 environmental keys, and we will call them in set Postgres config. So let's stop here for a second. Go is a garbage collected language. So what it means that whenever something is not used anymore, it's gonna get wiped. It's not gonna be used, and that's all. So you might be thinking, okay, but what about my memory? I've just created 4 variables. I'm gonna use once, and what else? Maybe I should put them in set Postgres config and just call them from here. So this wouldn't be that good, because what happens if you move to any sort of another provider of keys? So maybe you want to slap HashiCorp Vault into here. So then you would have to do another setup to set everything up from start, from ground up, to get the variables where you want to, and then change the code and do all of that stuff, which is just waste of time basically. So we have os.getEnv. We don't have to do the checks because we've done it already, and this will get all the 4 environment keys to our variables, and then we'll call the broker with all the variables. I will show you what set Postgres config does later on. So you don't have to, okay, this is a very good question, Khosrow, if I say the name right. So you don't have to define the type of this, because this will do the type assertion for you. So Go, if you call os.getEnvironment, it will always return a string. So if you have any sort of environmental key, it's always a string. If you want to treat it as a number, well, you have to cast it as a number. You have to change it to the integer. In our case, we don't have to deal with that, happily, because everything we need is in string. So you don't have to write type here. Yeah. Okay. Once we have that, we're gonna initialize the broker. You might be thinking, why this couldn't be in the broker? Why you couldn't do that somewhere else? Again, this is a very good practice that if you have multiple database and you want to be able to switch them on and off, you don't want to get all the logic from one place and put it in the other and just have one function that will play it all, because, well, this is bad design. In our case, we have three-step initialization of the database. So we create the over-top struct that will deal with the database. We set the config for the database, and then we call the database to check if it works. So here you can see that we're checking the error. Go deals with errors in a very fun way. So Go does this. So we are checking if the error is not nil. If you remember from main.go, we've been talking about zero values. Zero value of error is nil. So if the error is not nil, if the error is not zero value, then do something with the error. I'm just returning the error here. But in our case, if we convey that to this line here, we go, if broker initialize broker doesn't return any error. So if we actually have some errors from the initialize broker, we do log fatal f, and we notify the user that, hey, something's wrong with your Postgres connection. So again, fatal f is a combination of print to the standard out, and then OS exit 1. Yeah. Okay, so far so good, nice. Cool. All right. So another nitty-gritty. So now we create the router. So router is the thing that will get all of our handlers into one place and will deal with it. So then the versioning, I use prefix as a string. Mux has its own way of dealing with strings. This is the very, like, I have a very few places in the code I do stuff a bit differently. I found this way to be faster and easier. From my experience, Mux way of dealing with prefixes is not entirely production ready. It fails a bit, and then you have to, patch the whole API down. It's not the best, so that's why I use prefix. Another thing is that if you want to have dynamically created APIs, you can call prefix, and then you could do something like this. So if you want to run few instances of the same API and just differentiate the prefixes, you can do that, which is fun. Okay. And here we are. So this is our handlers. We're gonna write one, so I'm gonna explain as we go. So I haven't actually told about Vim modes. Vim has various modes. So it has a normal mode in which you move around. If you look into the cheat sheet, it depicts how to move around. If you want to insert something, you type I. If you want to leave the mode, you type escape. You just click escape. That's why you can hear those mechanical keyboard noises, because, well, mechanical keyboard has a very nice and smug escape key, and it makes me happy. Okay, so let's create a handler for updating post. So to create a handler, you call the router, then you call the method of the handler, which is of the router, which is handle. And first thing we have to do is to define the route for the handler. So in our case, it's going to be prefix plus, we concatenate the string, post slash post ID, and close the string. So we have the first part of the route, and then the second part will be the variable that we will use in our handler. So this is a way how you work with this in Mux. Every single multiplexer will have its own way. This is how you do in Mux, and I think it's very straightforward how to deal with that. Okay, so then we have to call the method that will deal with updating the post. In our case, will be A, because the method will be assigned to app, and it will be update post. And then we need to set up the method for the handler on which it will work. So we do methods, and we're gonna stop here for a second. So as you can see from line 62, we have http.methodGet, http.methodGet, http.methodPost, and http.methodDelete. And probably you might be thinking, okay, but HTTP verbs should be just strings. So why won't you do, in our case, if it's update, it's going to be put. Why won't you do this? And this is perfectly fine question. So if you highlight, for example, method post, if you look at the corner, left-hand down corner, it will say const method post untyped string post. So HTTP, as the package HTTP in Go, already has all these verbs for us. So this is, again, another very nice way to deal with the methods. You don't have to remember how to type them. You don't have to remember if it's lowercase, uppercase. You can just do http.method put, and that will do it for us. And that will deal with everything that has to go here. You can see that get single post on line 64 is highlighted. That's because we will write the handler ourselves. I'm gonna check the chat. Nothing new in the chat. That's good. I hope that means that it's all good. And before we exit the file, there are two interesting things we need to do. The first one is this helper function. So this function from line 75 to line 87 will print all the routes we have in our API. Nothing crazy, it will just print them in the standard output. And then last but not least in our application is the function run. So the function run gets the router from our application, snaps around the course. So it will prepare that for deployment for all the default course policies. You can read about which course policies are set by default by the default function on the in the application documentation, in the package documentation. Then we inform the user that server is listening on the given address. In our case, it's host name, it's host number, and then we run the server. Easy peasy lemon squeezy. So listen and serve is an inbuilt function in Go that will run the server for us. So it will spin on all the routines for our server to run. Okay, why get single post is highlighted in red? Because we will implement it ourselves. It's not already implemented. I want you to write it with me so you will understand how each handler is written. Okay, cool, good, making good time. Okay, let's save it, let's quit it. Cool, nice. So before we will go into handler, I want to show you the broker. And maybe I will write it. I will write Vim properly. The thing is, so if you want to run the playground after we finish, and if you want to build the whole API from startup, you can go into our digital playground GitHub, or you can go to my private GitHub. You can fork it. You can fork the repo. You can go with the main branch, master branch, and then the master branch will follow you from start to finish on how to build every single step. The main reason why we are not doing it here, because the whole playground would be 4 hours or 5, which we don't want. Okay, so there are two very interesting things in our broker package. So I'm gonna show you right now. So first of all, broker is a struct again. The first thing you can notice right now is that it has lowercase name of the variables. What does it mean? It means that those fields are not exported. So if you want to use those fields anywhere else in your code, they won't be accessible. This is a very good way to hide the very in-depth implementation of your structs. It's just a very good practice not to export everything. So this is our, let's say, constructor in some sort. Bear in mind, this application, this is a live server we run. So this is a live server I run in many applications. It has been stripped down from very big chunks of the logic, but the core of it stays the same. So it follows every single best practice I found over the time I'm working with Go, and I'm trying to stick to them. As basically always, Uber has a very good guide on how to write very nice idiomatic Go. So if you want to do more with Go, I would point you there. So we initialize the struct here. Okay, let's go down. This is another struct I use for holding all the data for PG setup, and this is the first very important thing. So in handlers, you will see that we deal with entity called post. So then you might think, what is this post? Why do I have it? Who defines this post? Is it the same post as I will have in the database? And the good thing is that our application, the way it's designed, it's gonna create the tables automatically. I'm gonna show you how in a second. But first we have to define the struct that will be in this table. So the struct we have has 5 fields. The first one is a ID of type UID. So it's universally unique identifier. It's totally random. In our version, we will be using UID version 4. Then we have a title and a content of type string. So the very good thing here, the very nice thing, and you think you might be thinking about, why do I have the backtick JSON title? So Go, whenever it deals with JSON, you can specify what the name of the JSON field is, but you don't have to use the same name of the field in your code. So in our case, the JSON payload will be very simple. It's going to be title content. But if the title changes to maybe you're writing the application that will deal with that, you can just change it here and you don't have to change it anywhere else, which is a very nice thing. Then we have created app, updated app, which is a type of time. So far so good, I guess. And then the other thing I want to show you is set Postgres. So set Postgres in our case does a lot of very nice things. So the first thing, in line 85, we create the string that will connect to the database. So that's why I've set up the PG setup struct up there, because right now I have all the setup fields in one place. So I create one string, then I open up the connection to the database, check if there's any error. If there's any error, I'm going to return the error, and then I'm going to notify the user that, hey, there's an error. This is a line in which you might change if you run the application in the production. In our case, we like to see what kind of calls the application does to the database. So we want to log every single call that will be done to the database whenever any handler wakes up. And then this is the thing we all been waiting for, auto migrate. So you can see that we have this ampersand, post, and the curly braces. What does it mean? It means that whenever the application runs, it will connect to the database and check if the setup of the database is the same as the setup of our structs in our application. So if you run the application for the first time, as we will do, it will show that I've created a table, and it will show how it has created the table. If you change something in the post, it will change it in the database later on. So you don't have to worry that much about the migration. The ampersand depicts a pointer, but we will talk about pointers in a second as well. Okay. I think that's all from the broker. I'm gonna check the chat. Is it common to abbreviate them to the first letter of the name? Yes. Yes, so like, if you do the app and then the star app, I'm gonna show that in the handlers, because that's gonna be very nicely depicted in handlers. It's a very common practice to just use one letter, because you don't want to type app if you can use a, because within that scope it's gonna mean whatever you want it to mean. Okay, so if we go to handlers, this will open our file with the handlers. Yeah, I hope it's not as hot in your place as it is in mine, because literally the sun is out there and it's very, very hot. But yeah, it doesn't matter. Okay, the first thing I want you to see in our handlers file is the thing that we have on the very bottom. So if you do capital G right now, so Shift G, Vim will go straight to the bottom and we will see what we want to see. So here we have a very nice function, func JSON response. So how handler works. Whenever you call a handler, you have to do some logic in the first. First you have to do some logic, then you have to check something from the database or authenticate the user or whatever. Then if it works, then return it to the user. You have to write the header, you have to return the code, you have to do all of that stuff. And 9 out of 10, if you're writing a very big API, probably you're gonna forget about it. So that's why we use a very nice wrapper function that will generate the JSON payload for you, that will set up the header for our front-end application to understand what they are dealing with, or for any application that will deal with our API. Then we write the header code, so we will know if it has failed or not, if it works or not, and then we write the response to our response writer. Very simple. It's just very idiomatic to have one function that wraps this logic, because then, well, it's more dry. I can see, can we also create DB indexes through Go? Yes, if you use Gorm, yes you can. Okay, we need to implement get single post. So if you do right now $GG, it will take you up to the top of the file. So, okay, so let's go. Very nice, very slow. So line 21, it's get all post. We don't have to worry about that. If you want to read after, please do. I've tried my best to explain every single line, how it works. What's the time? 54 minutes. We're making good time. Yeah, I'm really happy about that. So if you go below that, so if we go below this function, you will find the to do, create the method for get single post. So again, it's going to be line 53 in all of our instances, and let's get cracking. I'm going to check here if there's any extra questions. No, we're fine. Nice. Line 54, let's get cracking. Okay, so we have to create a function. Handler is a function. Simple as that. So func app capital A, get single post. Oh, typo, get single post, HTTP handler. My keyboard hates me. And that's all. So I'm gonna stop here for a second. So this bit, the A star app, will mean again that this is referencing the type we have. This is a pointer, and I'm gonna talk about pointers in 7 lines, literally. In here, in our handlers, we use decorator pattern. Why do we do that? Why won't you just do a very simple bundler and just return the function? You've said it's a function. Why won't you do that then? It's because there are very high chances in your application that you won't have just single database. If it's a enterprise grade application, there are very high chances that you will use Postgres, you will use another database, you will use some legacy, you will use Mongo because somebody has created a module with Mongo. So you want to be able to choose the connectors you want to have in your application in each handler. You want to be flexible enough to be able to switch around them. So in our case, we will do this. A broker get Postgres. So if you would go to our broker function, into our broker file, you will find get Postgres function. Get Postgres returns the database connection we will use from our handler to work with the database. Okay, and this is where the decorator pattern shines, because right now we will be able to return the function with the pre-set up database connection. So we do return HTTP handler func w HTTP response writer or HTTP request job. I'm gonna close it all just to have it nicely done. Beautiful. Okay, so we have our outer struct, outer thing, which is database connection, which will be accessible anytime you call this handler. So this is again a decorator pattern shines here very bright, because this variable won't be collected by the garbage collector. It will be here until the application goes down. So whenever you will run the handler again, it will be already ready for you. Okay, so if you remember, the get single post had a route like this: post ID. Okay, so we have to get that post ID somehow. In mux, we do it like this: vars mux.vars r. So this will check for any variables in our handler route and will return them as a map of strings. So like key value pairs of strings. From key is a string, value is a string as well. Okay. This is the first thing we have to set up. Second thing, we have to set up a return from our database connection. So we do var post. As you remember, post is our type that will deal with the database connection. So everything we'll get from the database will be smacked into the struct. And here you might be asking, okay, you've set up the database before the return. Why won't you do the same with the var post? If you would do the same, then remember, as I've said before, it won't be garbage collected. So if you get something to this variable, you will be either have to be sure that it will be reused, or it won't change the type, or it will stay the same. This is the thing we have to think about when you work with garbage collected languages. So if it's going to be reused, make sure that it's going to be reused in the correct way. In our thing, it's better to be safe than sorry. That's why we initialize the variable here, and then we gonna get all the values into this variable. So, and the third part, we need to close the stream from our body. So to close things like this, or to invoke any function after the function runs, I know it sounds silly, but bear with me, it's not gonna sound this silly in a second. We're gonna do our body close. So when the line 58 vars, so is this. It won't be highlighted in literally a second. Yeah. So the fur, it's a keyword in Go that means that whenever the outer function runs, the outer function returns, then you hit this function. So we want to close the stream of data from our handler. We want to be sure that we don't have any memory leaks here. Okay, so once we have this, then let's do the database connection. So we want to connect to the database, and we want to check if there's any error while we connect to the database. So we're going to do error, colon equals, and right now we do db, because we have created the database connection before. We need to specify, we don't actually need to specify. Gorm would be will be smart enough to do it for us. It's just a good practice to write code which is very easily readable, so you don't have to wrap around it with that many comments. So we do table posts. Gorm will create any table name plural, so it will follow the best practices for creating PSQL databases. Table post, and we need to find that one specific post. So we do where id equals question mark, and then we pass that vars we have in line 58, which is post, so square brackets, post id chap, and then the first return from this function is the post we're looking for. So first post error. Okay. Cool. Right. Nice. Fun. So I've been talking about pointers a lot. So the pointers, think about pointers like this. So if you work on your Word document, you would have to pass it around with your colleagues to be able to work on the same thing. So you will have to pass it around, and everybody will get the copy, write it down, write whatever they have to add, and then send it back to you. But if you want to have some way of collaboration around those files, you can create the Google Docs, for example. So think about pointers in the same way. We have on line 54 that star app. So it will point to the app struct. So it will use the same struct again and again. The same goes with line 61. The ampersand will reference the variable we have on line 59. So it will return to this variable. Okay, we need to check the error. If error is not nil, we need to inform the user, and then we need to return the call from the API that, hey, there's something broken right now, and we don't know what, and you have to deal with it. So the first one will be log printf. In this case, we don't do fatal because we don't want to fail. We don't want to get the whole application down. We just want to return the error to the console. So we just get single post %v error. So the %v will format the string for us. So we will return the error here. And then we can use our aforementioned JSON response function. So if you type JSON response function, we do W because we need to write into something. And if you look at line 56, we have response writer. So this is what we'll write into the response. Then HTTP status internal server error. So if you worked with any sort of APIs before, the status internal server error is 500. So you can type 500 here, but again, the same principle as we have in main.go. We want to follow the best practices. We don't want to mess around with different types, whatever. So if HTTP package already gives us whatever we need, let's use that. So that's why we have this. Okay, we've created that. Now we have to return the JSON payload to our user. So map string interface. And I'm gonna talk about interfaces in just a second. Chap. This. Okay. Cool. Okay, you might be thinking, what is that map, square bracket, string, interface thing? So, as I said previously, we have key value pairs as map something something. So if you do string string, then the key has to be string, the value has to be string. If you do interface, this is a very nice thing about Go. It's in the cheat sheet as well. If you do interface, it will inherit the type of whatever you pass into it. In this case, the interfaces in Go are very powerful, but we don't have to worry about this now. So in our case, if the error will not be a string or will be of type error, or you will create a very nice custom struct that will deal with the errors in some way and will send something to the user, you can pass it here and you don't have to worry about the type of this error. So this is a very good thing. Okay, and last but not least, we need to return to the user the result of the call. So we do JSON response WHTTP status, okay, which is 200, and then we return post and then save it. If you have any questions, shoot them now. I just needed a quick sip of water, so. Okay. It's all good here. Jillian, could you explain your question a bit more? Because I'm not sure if accounting for other errors. So in this case, when you work with the handler, you don't worry about the errors so much. So if you have the error somewhere down, you want to bubble it up and return to the user, and then the user will do something with it. So in the handler, you don't want to do this big, checking of the errors. So this goes down very much into design of your application. So this is another very big topic we would spend days talking about. It would be fun, but it would be very lengthy. Okay. So right now, assuming that we did all good, if we type go run dot, our application should run. Okay, fun times. Let's see if it runs. So I'm gonna go run dot. And then you can see that our go run has fetched some packages, has fetched the packages in the newest version we want to have. If you want to specify another version, you would have to do in the Go mod. You would have to specify which version. And then look at the create table. As I've said, Gorm is intelligent enough for us to create the table from ground up. So it will create a table of of UID type content created at and updated at with primary key of ID. The question I kind of presume that might happen: what if I want to have another primary key? What if I want to have foreign key? You can set it up as well, and you don't have to worry about that stuff. Okay, nice, good stuff. There's two things that left for us. First, we need to check if our API actually works, and then second thing, I've promised that we'll write the Docker file as well, so you will be able to run it in your Kubernetes cluster or whatever. So let's do these things. So I'm gonna open another terminal. If you use the web browser, you can open another terminal, or you can open Postman if you have it. If you use terminal, just open the new terminal window. I'm gonna open up the new terminal window somehow. Yeah, cool. Okay. Yes, now it's open. So I'm gonna do the easiest checks of our API humanly possible. I'm just gonna smack some curl calls into it. So the first call, we want to see if we can get some posts. So we can do curl localhost 900 API post. So if we done everything right, this should return an empty array. And it doesn't. And I know why, because I'm running over SSH. Yeah, okay. So this is the first fail I've been looking forward to. So I'm actually gonna show you how it will work, because I have the thing set up, because I knew I will fail. This is a very nice thing about live coding. You know that you will fail somehow. Probably I would have to use tmux here. So I'm gonna just run it here. Okay, so if I do go run, I'm gonna run it here. So this application is exactly the same as we wrote it. It's nothing has changed. It's the same application. I just want to show you how you can test it. So we can do the first call. It's curl to localhost API post. So this will return something because I have something in my database already. In your case, if you will do this curl, it will return nothing. It will return an empty array. Right now I want to add a new post. So I have it already. So I'm gonna create a new post. Let's change the post content as well. I'm gonna call it dpg live fail, because I failed a bit. And then I'm gonna write nobody saw it. Nobody saw it. Okay, if I call this, it should return nothing. But on the left hand side, you will see that we have insert into. So our values has been inserted in the database. So if you do the localhost again, you can see that this thing is already in the database. So, okay, nice. Let's get this one single post here as well. So I'm going to copy this, and I'm going to call curl localhost 9000 API post post ID. Ta-da! Nobody saw it. Beautiful. Okay, let's update the content to actually depict the truth. Curl x put the content It's on YouTube. That's the truth. Oh, sorry. Localhost 9000 API post ID. So you can see on the left hand side, again, it has updated the post for us. So if I fetch the post again, you can see, well, it is on YouTube. Again, I'm gonna delete all of this so it won't be visible again. Localhost 9000 API post. And you can see on the left hand side, it has been deleted. Okay, so this is how you can test the basic functionality of your API. Last but not least, let's write the Docker file. This is all what we've been waiting for. So let's write the Docker file. Docker file is very straightforward when you use Go modules. It is very nice. So let's type vim Dockerfile. I'm back in my SSH instance we've created for you, which failed miserably because I forgot about it. Sorry about that, guys. Yeah. So let's start the Dockerfile. So as any other Dockerfile, we start with from Golang. You could use Alpine here. You don't have to. Golang is perfectly nice. Then we do this magic. So I've said that Go uses modules for managing dependencies. Before Go 1.11 actually, we've been writing everything in GoPath. GoPath was our main directory of the whole application where all the packages were written in. So you would have to keep everything in one place. But right now we don't have to do that. Let's enjoy. So environment, this environment variable will make sure that Go will understand that it has to use modules here. Okay, work there, app, then copy go.mod, copy go.sum. So if you run go run dot, it has created go sum. So this is lock in time which versions of our of the packages we're using in our application. So then run go mod download. So fetch all the packages, copy everything we have. So we've prepared everything. Then run go build -o playground. I'm gonna call the executable from Go playground. So if you would run that in your terminal, it will return the executable called playground. Then we need to expose the port 9000, and then we need to tell the entry point, which is playground. Okay, I'm gonna stick with this screen for a second. Questions. Alex has asked, what stops it from returning both the error and the success response? Does the first call to JSON response somehow prevent the second one from executing? It doesn't. If I haven't written return, it would have two returns. So this is another bug that I'm gonna check it actually in a second. So I'm gonna get back to here. Vim handlers go get single post. Have I forgot about it? Yes, I forgot about it. So in your return from the error, you have to do return, because otherwise it will, well, it will return both. The one JSON response will be bad, the second one will be okay. No, actually, it will return the only first one, but Go application will yell at you, hey, you tried to write to close stream, you tried to write to something you already respond already. So you have to remember about that. So good catch, Alex. Cool. So we have the Docker file. So the only thing left for us is to do Docker build. And let's see if it works. So this is the most exciting part about Docker builds. if you will inspect the size of Go executables, you will see that they are quite big. This is for various reasons, but you can slim it down. If you want to play around with it, I highly encourage you to do so because it's really fun to understand how Go compiles Go. It is really fun. Yeah, and with this beautiful step, we have built our application. So, yeah. Okay, so from this point, what can you do to improve the application? So, you could separate the handlers, the DB actions from the handlers. You could separate the calls to the database to actual code that will call the database into somewhere else, into some other part of the code. Handlers could have more robust checks. So you could check if the post ID is actually what you expect to be as UUID version 4, because we don't have that. There are no tests for the API. Bear in mind, we are on 81 minutes mark, so I thought that we won't do the TDD way of writing the application because it would take us way more time, but it would be nice to have some tests here. Postgres or the broker package might be written as an interface, so then plug and play of the any other database would be even more seamless. But if you go to the master branch of this repo, the API is ready to go. You can just fork it, use it in your company, use it in your projects, add some stars if you want to, and then you can do whatever you please, whatever you like. This can be your starting point into writing Go on a production level. Yeah. So that said, thank you very much, very, very much for staying with me for the 82 minutes of our playground. If you have any questions, I'm gonna stick around for the next 5-7 minutes, and I'm more than happy to answer any of your questions. From tomorrow onwards, you can find, you will be able to find the series I will do on writing the same API but without using any packages. So we will write the same API as we wrote here, but without using any packages whatsoever. If you want to read about that, go to akondas.com. I'm more than happy to see you there to hear anything you want to say to me. If you want to catch me on Twitter, catch me at Artur Kondas. If you want to catch me on LinkedIn, feel free to add me to your contacts. I'm happy to talk about Go. Yeah, what can I say? Again, thank you for being here. Go has amazing community when it comes to open source. So if you want to start writing open source, if you've been wondering if that's good for you, just do it. This is the best way to learn Go, and this is the easiest way to learn Go. So you can do that. If you want to learn more, again, go to my blog, catch me on LinkedIn, catch me on Twitter. I'm more than happy to help. If you want to learn more about DevOps tools, we are doing this every month, and we talk about different stuff. So next month is gonna be a very fun one. I'm looking at you. So please join us. Yeah. Okay, one thing about the modules. Can you repeat the very earlier thing you mentioned about creating a module? Yes, I can. Okay, so going back here. So whenever you start a module, whenever you start the new package, whenever you start the new Go application, you have to go mods init and then the name of the application. So this will create the Go module thingy for you, and you will be able to run it. Yeah. We'll keep the instances for you for a second. So if you want to play around, just go. Okay, sorry if that was mentioned error on, but why would we check error is not nil? Okay, that's a very good question. I'm gonna create a question here. Questions go. Okay. So why check? Okay. So when we write some code, I'm gonna do a function that returns two values. So one, an error. Okay. So this is my func. Of course, Vimgo will probably highlight that in a second, but let's not worry about this. So right now, we need to see what happens with the error. So if I wrote that, then I don't know what the error is. The error is just a variable just somewhere in the space, so I need to check if that error is actually an error. So that's why I do if error is not nil, then let's just log fatal it for now. Fatal error. So if the error is not nil, then just log the error, because if you write it without this error is not nil, then you just have a variable error that you don't use, that you're not using. And good thing about Go being compiled language will be that it will yell at you and will just go, you can't use it, you've created a variable, please do something with it. And if you want to be reckless about it, so this is reckless way, you can do this. Okay, so this will mean that you return two values from the func, but you're only interested in one of these. So if you have a function that returns, I don't know, 4 values, you have to start thinking if that function is correct. So you can do this, and then you will get just the third value. Yeah. So, but please don't do that. Ignoring errors is a very bad thing. It's good when you try to check some package very fast in 5-minute time. Other than this, don't do it. Literally don't do it. Yeah, okay, another question. You said that there's a very flat style of coding, and is there's okay. So what I meant by flat style of coding is that shut up. So the flat style of coding in Go is keeping every single file in one directory. So we don't branch out into packages, we just have everything in one directory. The other style would be to create a package folder, to create the bin folder, and divide the application layers into separate packages. So this will directly affect how you deal with the code, basically. Yeah. Did you create a module within a module at the beginning? No, I'm not Christopher Nolan. I'm not brave enough to create a module within a module. So at the very beginning, we have created the modules. We said to our Go application that it has to use Go modules. If it wouldn't, you saw that it will yell at you, I don't know what the packages are. So if you start reading about Go, it will tell you you can either use Go modules or you can use Go path. The Go path, as I said before, is the way how you set up your Go environment to know where all the packages are. Is there a recommended folder structure, a Go way of creating a project? It very much depends. So if you go to Kubernetes, actually, let's take it as our second last question. So if you have any more questions, now is the time to pick it. I'm gonna pick one. If we go to Kubernetes on GitHub, because I think this is the best example. So one day it will open. Okay, so Kubernetes, this is a very good way on how to start reading about Go. So you can see that they have package, they have API, they have CMD. It very much depends on the application you want to create. So bear in mind, Go is very young language. It's only 10 years old. It's gonna be 11 this year. But a lot of stuff we develop as we go. I like flat structure. I like to do the package structure. It always depends on what you're writing. It always depends on the type of application you do. Go Path, Go Home, are they both relevant still? Yes, they are. I use Go Path more than I use Go modules because it allows me to do a lot of hacks in Go. But this is a topic for a proper blog post or for another conversation. Is there a Go equivalent of create React app which creates a template app with default file folders? No, there is not, which is actually a very good idea for an open source product. I will think about it. Yeah, but there's no need. You can write the whole full-blown Go application in just main.go. So this is a very beautiful thing about Go, that it allows you to be flexible about how you code, what you code, and when you code. Cool. Okay, that said, guys. Again, thank you very much for sticking around for this last 15 minutes. And see you next time. Again, catch me on LinkedIn, catch me on Twitter, catch me on my blog, whatever, whenever it's convenient for you. I'm gonna be more than happy to help you with your Go invaders. I can speak right now. So, cheers, guys. Thank you very, very much. Bye.